children. In the previous sessions, we studied on the arithmetic and algebra chapters. Today we will be starting with the geometry lesson. In your lower classes, you all have studied about polygons and its types. Yes, no? You know what is a triangle, what is a quadrilateral, what is a rectangle, what is a square. You know everything. So, in this lesson, we will be studying more about a particular polygon, that is a quadrilateral. It is a quadrilateral. You know a triangle. A triangle means it has 3 vertices and 3 angles. You all know. Triangle, it has 3 vertices and 3 angles. So quadra means 4, children. 4. A quadrilateral. We will be studying. So this about triangle you have studied in lower classes. So about the quadrilateral we will be studying in this particular chapter, that is understanding quadrilaterals. So before actually understanding what is a quadrilateral, in here you have a small introduction about the polygons and its types. We will just recall the things which you have studied in your lower classes. So what is a polygon means? It is a closed curve which is made up of line segments. You know what is a line segment? This is a line segment, this is a line segment, this is a line segment. And a straight line is in geometry, it is called as a line segment. Line anno badlu line segment anta we will say it in geometry. Anna, kemmu aden record agalla. ಉಗಿ ಬಾ ಕಫ ಉಗಿ ಫಸ್ಟ್ ಹೋಗು. ಅಷ್ಟು ಬರ್ತಾ ಇದೆಯಲ್ಲ ನಾ ಗೊರ ಗೊರ ಅಂತ. ಇಲ್ಲ ಇಲ್ಲ So a closed curve made up of such line segments are called polygons. Here on the board I have drawn different types of polygons. It should be a closed figure. Okay, it should not have open ends like this. If it is a closed figure and which is joined by the line segment. See, this is a triangle, 3 line segments, and it is a closed figure, hence it is a polygon. Here you have a rectangle which has again 4 line segments, which is the closed curve, again it's a polygon. Here this is one more different type of a figure, that is a polygon, which has again line segments and it is closed. You observe one thing, children, everywhere you have straight lines, nowhere you have curves, as well as you see that all the geometrical figures drawn here are closed. That is very important. Such figures are called polygons. If now, how to identify non-polygons means, see, just a V, a W, they are not closed. Though they have line segments, they are not closed. Simply if I close, this becomes a polygon. If I erase these lines, this is no more a polygon. Like that it is. So see, it should be a closed curve. All these are the examples for non-polygons. So this is about polygons. Next you have the concept of diagonal. Before that, children, these polygons, how do you classify? Means they are classified based on the number of vertices they have, number of vertices and number of angles they have. You here only we studied triangle means it has 3 vertices. A square, it has 4 vertices. You have studied in your lower classes about a polygon which has 5 sides is pentagon. A polygon which has 3 sides is a triangle. Which has 4 sides is a quadrilateral or a square or a rectangle. I think you can tell. 5 sides pentagon, 6 sides hexagon, 7 sides hectagon, 8 sides octagon like this, n sides nonagon, 10 sides decagon. Deca means 10 like this. Polygons based on number of vertices and number of angles, they have been classified, children. So that is one more thing. In your textbook, if you open page number 50, you have a table given here based on classification of polygons. So you can go through it. You have a triangle, a quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon in general. So up to 10 sides, decagon we will tell. What if it have 11 sides? What if it have 12 sides? This question may arise in your mind. So in general, n-agon, n-gon, we will tell. Yes, n-gon, G-O-N means hectagon, hexagon, heptagon, octagon, like that children, pentagon. So n here means this number. Hyphen gon, G-O-N. Gon means not G-O-N-E, gon. This gon is different. It is just G-O-N. It is used in classifying the polygon. Polygon. We have studied about the polynomials in algebraic identities lesson. Yes, no? Polynomials. Poly means 4 or more than 4. We will tell. Here also, poly means any number it may be, like 7, 8, 9, 10, 6, 5. And gons, here also we have gons, the term gons. So like polygons, like polynomials, polygons are gon word we have, no? So hexagon, heptagon, octagon, pentagon, like that gon will come, children. So polygons are being classified based on number of vertices and number of angles they have, and you can have a glance with this table, and I want you to write this table as well in your classwork. Next, they have introduced the concept of diagonals to you. What is a diagonal? It is also a line segment. Line segment means, don't get confused, it is simply a line. In geometry, we say a line segment. A line segment connecting, this word is very important, non-consecutive vertices of a polygon. So, any polygon you can consider to explain or to draw the diagonal. Any polygon you can consider. And a line segment, that is a line segment, means a line should be drawn in a polygon. And simply, I cannot draw a line like this. Instead, it should connect non-consecutive vertices. Means, children, to explain you that, I have here considered various polygons. See, for now I don't want triangle. I will consider this square. A, B, C, D is a square. I want to draw the diagonal for this quadrilateral or a square, we can assume. In order to draw, children, I should draw a line. Why? Because they are telling that a diagonal is a line segment, but it is connecting non-consecutive vertices. Consecutive means, even in rational numbers chapter, find out the consecutive numbers like that, one after the other. 1 means next is 2, 2 after 3, 3 after 4, like this. 1, 2, 3, 4 are consecutive numbers I taught you. Here also, which are the consecutive sides? A, B are consecutive, B, C, C, D, D, A are the consecutive. But non-consecutive sides or vertices, if you join, that line segment is called diagonal, they are telling, children. So, non-consecutive means, see, A and C are non-consecutive. Why? A and C are not one beside the other. Similarly, B and D are non-consecutive. Why? Because they are not one beside the other. So, if at all I want to draw a diagonal for this square or a quadrilateral, AC is the diagonal. Similarly, BD is the diagonal. There are only 4 vertices, means only 2 possibilities of drawing the diagonals are there. That is, we are joining the opposite sides. So, non-consecutive sides means one beside the other. If you have the vertices, children, you should not join them. Non-consecutive vertices, if you connect with the help of a line segment, then AC is the diagonal. Which are the diagonal? AC and BD are the diagonals for the square ABCD. Similarly, 1, 2, 3, 4, 5, 6, 7, 8. I have drawn an octagon for you. Why? See, A, B, C, D, E, F, G, H. H is the 8th letter, and this is an octagon. In an octagon, if you want to draw the diagonals, children, how would you draw? A, B, B, C, C, D, D, E, E, F, F, G, G, H, H, A are the consecutive sides. So, you cannot join them. But you should join or connect the non-consecutive vertices. Means, I can join AC, I can join BH, I can join AD, I can join CD, I can join HE, I can join CF. Like this, see, many diagonals I can draw in an octagon. Similarly, children, one activity I will give it for you. You should do it. For all the polygons, try drawing the diagonals and find out how many diagonals can be drawn. Keep in mind, like this, opposite or non-consecutive vertices only should be connected through lines. So that is a diagonal, children. So the definition is being given to you in a textbook. A diagonal is a line segment which connecting two non-consecutive vertices of a polygon. So after understanding what are polygons, its classification, and what is diagonal, children, now we shall study about the types of polygon. There are two types, convex and concave. You all have studied about the mirrors in the physics. In physics you have studied about the mirrors. Which are the types of mirrors you know? Convex mirror and concave mirror. So similarly here also in polygons, in case of polygons also you have two types of polygons, that is convex polygon and concave polygon. So what are these convex and concave polygon? How to identify by looking at the given figure whether it is convex or concave? How to classify them? Means children, it is very simple. If the polygons are like maybe a rectangle, a diamond, that is a rhombus, hexagon, pentagon, octagon, anything you can draw, children. All these, this has not come out correctly. A quadrilateral I will draw. So such closed figures, see, polygon means, of course we will generalize the definition of being a line segment and a closed figure for both convex and concave. But if they don't have interior folding, children, such polygons are called convex polygon. What is this interior folding means? You will understand when I draw the concave polygon. Concave polygon means like this. See children, such figures or such polygons, see, it is closed. It can see all the three which are drawn consists of the line segments and they are closed itself. They are closed itself. So both these are polygons. But if they don't have interior or foldings or such shapes, children, then it comes under concave polygon. If not, it comes under the convex polygon. Here they have given the definition. Polygons that are convex has no portion of their diagonals in their exterior or any line segment joining two different points in the interior of the polygon lies wholly in the interior of it. Means they are explaining it in terms of the diagonal. Polygons that have convex have no portions of their diagonals in their exterior. Yes, no? Convex polygon means, children, the diagonals, they don't have exterior. But here, in case of convex, then they do not have the line segment joining any two different points. Those are called concave polygons. Next, you also have regular and irregular polygons. First classification what we learnt are convex and concave polygon. Next, you have regular and irregular polygons. So, only way to differentiate regular and irregular polygon means, children, you know the meaning of equilateral and equiangular. Equilateral and equiangular. Equilateral means if at all the sides of any parallelogram are equal, then we say it is equilateral. Best example is, we will consider the triangle ABC. If in a triangle ABC, side AB is 2 centimeter, BC is 2 centimeter and side AC is also equal to 2 centimeter, then we say all the three sides of a triangle are equal. Such triangles are called equilateral triangle. If at all angle A equals angle B equals angle C in a triangle, then it is called equiangular. Name itself tells you. Angular, equiangular. Angles should be equal. Equilateral and equiangular triangles. So, if at all a polygon is both equilateral and equiangular, then such polygons are called regular polygons. If they are not equilateral or equiangular, such polygons are called irregular polygons. Example for that, children, you can see a triangle or a square. Yes, no, all the sides of the square are equal. Hence, this is a regular polygon. But if I consider a octagon or a hexagon, it is, see, all the sides are not same. Yes, no, these two sides are not same. Even in case of rectangle, if you consider, the opposite sides are equal in case of rectangle. So, this also cannot be a regular polygon. If at all the sides or all the angles of a polygon are equal, then it is said to be regular polygon. If not equilateral, or equiangular, such polygons are called irregular polygons. That's all, children. So, this is about the introduction part of this lesson. Next, you have, yes, one more thing, that is angle sum property. Angle sum property also you have studied in class 7. Angle sum property. Just now it is not SOME sum, but it is SUM sum. Angle sum property. Here I am telling you about a triangle. Angle sum property of a triangle. Just now I said you what is an equiangular triangle. If at all in a triangle all the angles are equal, then such a triangle is said to be an equiangular triangle. So, if at all the angles are equal, then what should be the value of, similarly, you have three angles, angle A, angle B and angle C in a triangle. If you want to have angle A equals angle B equals angle C, then what should be the measurement or value of each angle is the next question we get. So, obviously children, you all have learnt, no? This should not be equal. If at all they should be equal, then the sum of angle A plus angle B plus angle C is 180 degree. That is, if at all angle A equals angle B equals angle C is equal to 60 degree, then when you sum up 60 plus 60 plus 60 is 180 degree. So, the sum of three interior angles of a triangle is equal to 180 degree. That is the angle sum property of a triangle, which you have already learned. So, it is just a recall of it. You consider any triangle, and if you consider the sum of all the three triangles, then it is always equal to 180 degree. If at all it is an equiangular triangle, then all the angles will be equal to 60 degree. If it is not equiangular triangle also, then any triangle, right angle or any type of triangle you consider, children, the sum of all the three interior angles should be equal to 180 degree. That is the angle sum property of a triangle. So, what all we discussed is, first we studied what is a polygon. It is the line segment and a closed curve path that gives you a polygon. And in polygon, how do you classify polygon? Based on number of vertices and based on angles, like triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, like that. And we studied about the types of polygon, that is convex polygon, concave polygon, and how the figure will be also, and how to classify, identify also we learned. Next we studied about regular and irregular polygons. If at all the polygon is equilateral and equiangular, then such polygons are called regular polygons. If they are not equilateral or equiangular, such polygons are called irregular polygons. Next we discussed on the angle sum property of a triangle. That is, the sum of all the three interior angles of any triangle is equal to 180 degree. This is the angle sum property. With this background, children, we shall solve the first exercise, that is exercise 4.1 in your textbook.